Today, we're continuing our series on integrating testing into your development flow. Today's topic, we're going to be applying software patterns to test automation. This is primarily a high-level talk of software patterns. We will be having a series in the future that will probably expand further into each of these software patterns. They're just a little more outside of the scope of just actual testing. To recap, so far in this series, we have covered how to write testable code, looking at ways of defining and implementing a test strategy and a test plan. We looked at using unit testing to test our applications and our software. We also looked at how to write tests using TestNG. And also, we did a more detailed couple of sections on how to get our hands dirty and actually get down nitty gritty with TestNG with things like the basic annotations, executing tests, look at the different types of suites, and how you can execute and using parameterized testing, dependency testing, and so forth. We also looked at creating customized reporting and using the default reporting in TestNG, as well as looking at the Selenium tools and combining Selenium with TestNG. So today we're going to kind of break away from the coding side and actually getting into the testing side of things and look at a more abstract view of design and software development which is a design pattern. So we're going to talk about what is a design pattern. We're going to look at what kinds of patterns do developers use. Are there any test-related design patterns? And why are patterns important? So to start with, what is a design pattern? So in software engineering, a design pattern is a general repeatable solution to a commonly occurring problem in software design. So design patterns are not a finished design that can be transformed directly into code. It is a description or template for how to solve a problem that can be used in many different situations. Design patterns are also used to represent some of the best practices adapted by experienced object-oriented software developers. They are generally designs that address a recurring design problem in object-oriented systems. They also describe the problem, the solution, when to apply the solution, and its consequences. It also gives implementation hints and examples. Overall design patterns, there essentially are two main usages in software development: common platforms for developers and best practices. Design patterns provide a standard terminology and are specific to a particular scenario. One example I found is a MVC design pattern, the model view controller design pattern specifically, specifies that applications consist of a data model, presentation information, and control information. The pattern requires that each of these be separated into different objects. MVC is more of an architectural pattern, but not for the complete application. So all developers familiar with the MVC design pattern will make use of these objects, and they can tell each other that the program is following a MVC pattern. That way, different developers or new people you bring in, or if you outsource your software, you can say, hey, this is a model view controller pattern, and they should know how the software is written, be able to go in and actually make updates and changes to the software. As for best practices, design patterns have been evolving over a long period of time, and they provide the best solutions to certain problems faced during software development. Learning these patterns helps unexperienced developers to learn software design in an easy and faster way. Patterns have been around for a long time. They're kind of tried and true, object-oriented and design structures that people have come to determine that are the best practices or ways of doing things within software. So what kind of design patterns do developers use? Well, there essentially are three types of design patterns that these patterns fall into. We have creational, we have structural, and we have behavioral. In creational, in software engineering, creational design patterns are design patterns that deal with object creation mechanisms, trying to create objects in a manner suitable to the situation. The basic form of object creation could result in design problems or added complexity to the design. Creational design patterns solve the problem by somehow controlling this object creation. Structural patterns explain how to assemble objects and classes into larger structures while keeping these structures flexible and efficient. And then behavioral These design patterns are specifically concerned with communication between objects. So let's look at the different types of patterns for each, starting with creational. So with creational patterns, they typically consist of things like the abstract factory, builders, factory methods, singletons, prototypes, and objects pools. An object factory creates an instance of several families of classes, whereas builders separate objects' constructions from its representation. Factory model creates an instance of several derived classes. Singleton is essentially a class of which only a single instance can exist. Prototype is a fully initialized instance to be copied or cloned. Object pool, avoid expensive acquisitions and release of resources by recycling objects that are no longer in use. Next, we have our structural patterns. In here, we have adapters, bridges, composite, decorator, facade, flyweight, private class data, and proxy. So the adapter is a structural design pattern that allows objects with incomplete interfaces to collaborate. The bridge is a structural design pattern that lets you spill a large class or a set of closely related classes into two separate hierarchies, abstraction and implementation, which can be developed independently of each other. Composite is a structural design pattern that lets you compose objects into tree structures and then work with these structures as if they were individual objects. The decorator is a structural design pattern that lets you attach new behaviors to objects by placing these objects inside specially wrapped objects that contain the behaviors. Facade is a structural design pattern that provides a simplified interface to a library, a framework, or any other complex set of classes. Flyweight is a structural design pattern that lets you fit more objects into the available amount of RAM by sharing common parts of state between multiple objects instead of keeping all of the data in each object. Private class data, kind of self-explanatory, is class data that's defined privately. Proxy is a structural design pattern that lets you provide a substitute or placeholder for another object. A proxy controls access to the original object, allowing you to perform something either before or after the request gets through the original object. Some behavioral patterns, we have chain of responsibility, which is a design pattern consisting of a source of command objects and a series of processing objects. A mechanism also exists for adding new processes objects to the end of this chain. Next, we have our command pattern, which encapsulates a request as an object, thereby letting us parameterize other objects with different requests, queues or log requests, and support undoable operations. Interpreter patterns provide a way to evaluate language, grammar, or expression. The iterator pattern provides a way to access the elements of an aggregated object sequentially without exposing it to underlining representation. The mediator pattern defines an object that encapsulates how a set of objects interact. Memento pattern offers a solution to implement undoable actions. We can do this by saving the state of an object at a given instance and restoring it if the action performed since needed to be undone. Kind of similar to database commit and rollback. So the null object pattern intent is to encapsulate the absence of an object by providing a substitutable alternative that offers suitable default do-nothing behavior or null. The observer pattern is used when there is a one-to-many relationship between objects, such as if one object is modified, its dependent objects are to be notified automatically. State pattern is used when an object changes its behavior based on its internal state. In strategy pattern, a class behavior or its algorithm can be changed at runtime. In template method pattern, an abstract class exposes defines ways templates can be used to execute its methods. Its subclasses can override the method implementation as per need, but the invocation is to be used in the same ways defined by an abstract class. This pattern comes under the behavioral pattern. Lastly, we have our visitor pattern, which is used when we have to perform an operation on a group of similar kinds of objects. With the help of the visitor pattern, we can move the operational logic from the object to another class. So here are some tester design patterns. We have our test implementation design patterns. We also have architectural design patterns and functional or UI design patterns, depending upon if your application has a GUI front end or if it's just a command line. So to start with, we have our test implementation design patterns. These design patterns focus on various areas of the test from the implementation perspective, looking at things like the recorded tests, module tests, data-driven, keyword-driven, hybrid, and behavior-driven. Now, as you can see from the image, these all kind of stack on top of each other. So they're all essentially expanding on the previous one. And they all come from the core framework. So that could be your unit test, that could be JUnit, that could be TestNG, it could be whatever your actual test framework is. Each of these expand upon that. So with the recorded tests, these are tests that are recorded by like an automation tool or a plugin in a browser. These are primarily to execute the tests. The recordings are played back as it was recorded, also known as record and playback method. Modular tests require the creation of smaller independent scripts that represent modules, sections, and functionality of the unit test. These smaller scripts can then be used in a hierarchical way to build larger, more complex tests. Next, we have data-driven. As the name implies, these patterns are based on test input and expected output values. This data is typically stored in a separate data file, which will be fed into a single driving script, then executes all the test cases with multiple sets of data. Keyword-driven. Keyword-driven test implementation is done through data tables and self-explanatory keywords. This framework is also an extension to the data-driven testing. Hybrid automation framework. This approach is a combination of both the data and keyword-driven testing. This combined approach helps us use the data-driven scripts, take advantage of libraries which usually accompany the keyword-driven tests. And finally, we have the behavior-driven tests, which are written in the form of simple text features describing in ubiquitous languages with scenarios typically written before anything else and checked by non-sequential shareholders. So behavioral-driven, these are things that you can actually take from the original software documentation or the use cases that are defined by the business managers or the business cases. These can be easily translated over into the behavior. How is the application supposed to work? Next, we have the architectural design patterns. These patterns focus more on architectural patterns, which is a concept that solves and delineates some essential cohesive elements of the software architecture. So here we have a multi-layer architecture. The test code is defined in a layered structure by splitting the code in layers on the basis of logic, of presentation, business logic, and data storage. In our meta framework, the meta framework design pattern provides a method for solving the problem of automating multiple pieces as part of a large automation strategy. In this pattern, testers define independent utility classes, which can be generally used with any automation tool and can be reused between different automation projects as well. This framework provides an abstraction layer that allows the separate automation pieces to be executed and have the results report back in a standardized way. Such a solution increases reusability in case different projects are tested inside one organization, and the unified interface of results is required. So let's look at the multi-layer architecture a little bit more. So it typically consists of three distinct layers. We have the topmost layer being the test case layer. This is where all the test logic resides. Test logic can be expressed concisely with the help of the layers below it. Test cases for different stories, scenarios, and corner cases rely on the same pieces of code in the layers below. The only difference is in the parameter or test data representation represent different classes. The second layer is the functional logic, or in the case of the domain layer, this layer will encapsulate operations to the system under test, like the URL concentration, response XML, HTML parsing, rich client GUI browser controls, and so on. It will present the system under test in the domain language rather than in terms of the XPath, SQL, or HTML. Finally, the third layer is the system under test, or as you can see in the image, SUT. In this case, it is for the UI automation tool, which interfaces with the automation unit test. This architectural approach ensures a low-code maintenance. Looking at this picture, so you have all your framework utilities on the right, so you can pull out like TestNG, all your different components like your logging, if you want to use SLF4j, log4j, database helper files, or text helper files. And then your layers, you start out here with your test scripts at the top, your functional libraries, your UI mappings. And then finally at the bottom, you have your automation tool, which interacts with the services, the browsers, and the different components. And then looking at the meta framework, here you have your test case management system. You have the meta framework, which talks to your framework and your tools. And this way you can actually abstract the layer, allowing the separation between the different pieces. Next, we have the functional UI design patterns. So this typically consists of functional methods and libraries, page objects, object repository, and page factory, and processing patterns. So first, with our functional method and library, this design pattern talks about writing separate methods for repeatable operations on the UI in order to keep the maintenance effort low in case of UI modifications. For example, the code to log into a web page can be written in a parameterized function method, which can be edited if anything changes on the login screen. Such methods are grouped together inside of a class, which is called as functional libraries. Instead of libraries, you could take the next approach, which is using the page object model or page object pattern. This page object pattern groups functional methods of certain pages as it helps to improve code maintainability. The functional libraries or page objects in the design pattern represents a logical representation between the pages of an application. Each class is referred to as a page object and returns other page objects to facilitate the page flow between pages. As an example, consider logging into Gmail. After entering the user details, the step within, whereas the user passes and navigates to the input page, or if it fails, the login page possibly due to an invalid parameter. So you kind of have two paths there. A pass would return the page to the input page object, whereas a fail would return the login page object. This design pattern ensures better test, exception handling, and reporting. One other thing to think about with page objects is if you take a sitemap of a website, every single page on a sitemap essentially is defined as a page object class with all the elements of the page defined in there, as well as all the methods for interacting and page navigation. Then you would potentially apply the third pattern here, where you have object repository and page factories. So an object repository allows the tester to store all of the objects that will be used in the scripts in one or more centralized locations, rather than letting them be scattered all over the test scripts. Whereas the page factory is used to initialize the elements of the page object or initiate the page object itself. If any object changes in the UI, then the tester just needs to update the locator in one of the centralized locations, thus minimizing the code maintenance effort. Again, so if we go update a web page, all we have to do is go change the page object for that web page. We don't have to actually go change any of our tests, unless, for example, we add or remove elements to the page that require us to actually change, not really the elements, but if any of the elements or components of a page change, which also changes its flow, we would then need to go update our test cases. But there again, you're only updating one or two places in your code. You're not updating multiple tests. And lastly, we have the process patterns. So the process pattern splits the test execution process into three stages. This gives us given, where we define the preconditions for our test. 2, when, which sets the specific operations to work with context. And finally, 3, which is then, which is where we check our results. So the process patterns essentially breaks down to given, when, then. So given some condition, when the condition is met, then do something. Behavior-driven tests use the process pattern in building tests in natural languages, which are easily understandable by non-technical people. So if we take all the patterns we've talked about and you kind of put them all together, this is kind of what it looks like. So in a very modularized approach to testing, you can break your entire test framework out into this very modular implementation. And what benefit you get out of this is you can apply multiple frameworks and multiple patterns to your testing environment, which allows you to essentially break out different components of your testing framework. So you can actually have different individuals or different parts of the company work on different things. So you can have an automation group which handles the automation layer, which is your interactions with Selenium, which also can contain snapshot pieces where you want to take pictures of the browser when something fails. At the logic level, you would have your design patterns, your page factories, page objects, your page flows. There again, you have app utilities. You want to report logging. At the actual test layer, things like unit tests, TestNG, create your test utilities where we have interactive reporting based on those frameworks like TestNG. But within these frameworks, you can also apply your configuration properties. Here you can apply the data-driven testing. You can do the hybrid testing, database testing. So this is where you feed all the data into your tests. And then at the top level, you have your suite level. So you can actually take and combine multiple test cases together. You can define smoke tests, you define full integrated tests, you can do feature testing, sanity tests, you name it. But this is a way where you can take everything we've kind of covered and put it together into your testing. So this is taking it from a development level. Now at a testing level, yes, you can do almost the exact same kind of modeling and framework patterns from a testing perspective. And if you do something like this to your test framework, I guarantee you're going to have a much easier time maintaining and building your test in a way that is maintainable, and not just maintainable, but also you can manually deploy them. You can apply them through continuous integration frameworks like Jenkins, as well as reporting. So you have all the components here that make a framework what you need. And you can piecemeal this. So if you really don't need the automation layer, you just need some basic testing, then stop there. But from here, you could take it pretty much to any level of extrapolation or abstraction. So what are some of the benefits of design patterns? Well, the low maintenance, effort and time, low maintenance cost, enhanced code reusability, enhanced reliability, structural code base, which is easy to fix and extend, improved communication. And again, if we go back here, you can see that it's much easier to maintain. You can visually break out the components of your test framework. You can also break up your layers. So you could have your testers actually focus on creating the test suites, the test cases. And then you could actually have your developers build the logic layer, the page object layers, where they take their pages. If they did model view controller, it's real easy. You take the views and you convert those over to page objects. And then you can even have the business analyst give you some test data, or even write out your test cases using the process patterns. Does anyone have any questions?
Hey, Michael, I was thinking about how to leverage these testing design patterns into, say, for instance, we're using MVC and factory pattern in our main application. How to leverage or integrate these patterns together? Have you done any work in that regard where you're integrating both the testing and design patterns, testing and production design patterns together?
Yes, I have.
That's cool.
So one of the ways to look at this, so just think of a website. You have a sitemap. So your site has 5 pages.
Mm,
So you would create 5 page objects in your testing environment.
mm,
But you would also want to create a page factory that essentially returns one of those pages.
mm, mhm.
And then within that factory, you could then also pass in different data sets for different scenarios. So like a login scenario where the login would pass, the login would fail. And then you could even take it one level further where your page objects could have 2 things. So you could have all your validation, your pass fail code. So like, is element displayed?
Mm,
Is
mhm.
this displayed? And then you also want to add all your actions to the page
Yeah,
object, like click button, enter text, populate user ID, log in, etc.
yeah,
But
yeah,
then you would possibly want to extrapolate out the page flow, the page interaction logic, actually move that out into the test layer and have the page flow actually define the test scenarios. A scenario page flow would be, let's see, home page or login page. User login, continue to, if you're Gmail, continue to inbox. Inbox, select email, continue to message. That would be out in like a page flow factory or a page flow. And then you would have like your data sets for each of the pages as well. So you could have one for login, one for inbox. But the reason you want to put your validation methods and your action methods in the page object is now all the code that actually interacts with the page is in one place. It's all in the page object. But say you want to add an assertion that a test is true or false, or an actual assertion case. You don't necessarily want to do that directly in the page object because you may want to use those validation methods for something else. Like you may actually just want to say, hey, is element defined before I do something? So what you would then do is you would actually extrapolate out another level and create an assertion factory, and then create an assertion object for each of your pages. And then what you can do there is then you can actually predefine your assertion messages. So then all your assertion messages like login failed, login user ID null, expected. So like you can actually define everything there. So you've now extrapolated out all your assertion tests into an assertion class. You have all your page logic in a page object. You have all your page flow in a page flow class. And then you use factories to interact with all these. And then you have essentially a data object factory for each data set, for each page data sets that you want to pass in.
Yeah.
So
Yeah.
that's where you kind of get into this model here, where it really abstracts out quickly.
hmm I was just thinking about that. It becomes, I guess it's just based on how far you want to dig into it and how detailed you want to be. Is there I guess, of an analysis about how, forgive me, I'm not trying to downplay the benefit, but I want to understand, is there analysis of how much benefit you get from uh, uh, going this deep into the layers of testing versus how much time is spent to do it, the kind of the cost benefit analysis of it all?
Well, let me put it to you one of two ways.
Sure.
You could do it this way. I mean, in this particular approach, you don't have to get this detailed. You can shrink it down quite a bit, but
Yeah.
still you want to do something like this versus record 1,000 tests, store them as 1,000 unit tests.
hmm
You go and change one page element, and you now have to go physically either re-record
Yeah.
1,000 tests, or you just go update one line of code.
Yeah. Yeah. That makes sense.
That's where your cost benefit comes in.
I'm with you. Yeah.
Because you say, yes, there's a cost to building this up front, but truth be told, you could probably build this, depending on how abstract an application is, in
hmm
probably about 2 or 3 weeks.
hmm
And then you just
Yeah.
have to build your unit tests, and then you're done. Most companies that I have worked with either don't have testing in place at all, or they have the
hmm
record playback method where they just have a bunch of recorded scripts that they have to keep going back and redoing, or they have some type of process patterns defined in a checklist that they have to manually go through every time and test.
I see.
And if you think about it, if you do, say if you do like annual releases, this approach may or may not be right for you. It may be more beneficial to you to actually go in and physically go in and test the entire application before it gets released. However, you still want to have some type of test cases. So in that case, a record playback might work, might not. But if you do quarterly, or hell, if you do monthly deploys, monthly releases of your software, and you have a test group, I mean, for one application, you may have 4 people manually testing that application.
Yeah.
Well, if you have 20, 30 code changes going in, they're not going to have time to go in and regress the entire application. They're really only going to have time to focus on what changes happen. So you're not doing a full testing of the application, so something can break and it won't get caught. Whereas if you go this approach and you actually take everything from the page level, you actually define out all the business action, basically all the process patterns, what the BAs, what the application is supposed to do at every page. How are you missing something?
Yeah, I'm with you.
In fact, you're more inclined to catch things if you apply these patterns than if you just do the record and playback method. And the reason I say that is because if you think about it from this level of extraction, you're going to look at your code, or you're going to look at your software in a different way, more from a user perspective, as how can the user break my site? How should my site work for the user? And then you're actually going to start asking the right questions and actually build the right test cases to essentially build your test suite in a way that your site will always be covered. Even if you keep adding new features, it'll be easier to add those features in as new test cases and adjust existing test cases than to do just record and playback. And if done correctly, this becomes your documentation. Because then you can look and say, well, here's our test suite, here's all our test cases. Oh, we want to go from Java to .NET. Well, here's what we need to do. We need to make sure it does X.
That's good. That's good. Thank you.
No, you're welcome. Any other questions?
Michael, how good are you supposed to be? I mean, do you have to know the workflow in order to design all these different automation partners?
So from a tester's perspective, if you're just coming in and doing unit testing or testing in general, you may start just at the test suite at the top level, where you are going to create either record playback or create a bunch of test cases and test suites for those test cases. Now, if you're going to start getting into automation, you're going to want to get down into using some other framework layer, like maybe TestNG, the .NET testing, and get into another layer there. And then, if you want to deal with web pages and not have to handle or go in and actually retool your tests every time a page changes, then you're going to want to extrapolate out again to the logic layer, where you actually get into the design patterns, the page factories. Also, if you go back up to the test layer, that's where you want to start creating your different data sets. Instead of creating multiple tests with multiple data sets, you could create one test case potentially with some conditionals in there and let your data actually drive the test. So like you could have it log in. So take a login page, for example. You have your data set and you have your login page. So on your login page, your test case could be user logs in, load login page, enter in user ID and password, click submit. Now, here, this is where you can do multiple page flows, but you could say, okay, if, say, input box is loaded, page is loaded, do X. So then you're going to go grab the input data set for the input page. That's one way to do it. Another way to do it is completely by data driven. So you look at your data and say, okay, do I have data for test user or for login user ID? If so, populate. Do I have data for password? Okay, populate. Click continue button. Do I have data for input box? Yes. Okay, then I should be checking to see if the input box page loads, meaning that that data set should be a valid data set and it should load the input, like the inbox folder of Gmail. If it doesn't, and if it fails, then we know that something has happened to our application, that our valid data set is failing. Either we're getting a page 500 error exception because the site's down, or something's broken. Or you could do it the other way, where you could put in a user ID and password, and then instead of looking is inbox data there, say is failed load or failed login exception page data present. And then if that's the case, then you drive the page flow from that to back to login page or to an actual another page. That's just a couple different ways you can drive this using extrapolating it out to this level. So you can actually create one test case, but drive it all through data. So you essentially define your site map essentially in one test case, and then you drive it all through data. I may have gone a little too far past your question, but
yeah, yeah, I got it. Thank you.
Hey, Michael, I actually thought of another question as you were discussing, it made me think of it. The situation in which your testing design pattern clashes with your regular design pattern. For instance, say I'm using decorator in my UI, and then the testing design for some reason, design patterns for some reason is flyweight. Would that create a clash or even an anti-pattern from the combination of the two?
No, because you have to think of this in essentially two different applications. So
Mm,
you have your software application, but then this is the test application to test your
I'm with you.
software
I'm with
application.
you. Yeah, yeah.
So there's
Exactly.
two layers to that. So you can have multiple patterns. In fact, you can actually add a facade pattern to your test pattern. You can apply any
Hmm.
of the developer patterns to your test patterns.
Yeah,
But essentially, you don't want to, because a lot of your developer patterns they get more extrapolated, they get more complex than we really need for testing. For testing,
yeah.
essentially, this is what you're looking at here is what you really want to focus on, because this
I
pretty
see.
much covers everything you're going to really run into with testing.
I see. I see. That's good.
I mean, the only thing you don't really see here is because this focuses primarily on like a page factory model here, where you have the Selenium implementation. But what you could have here is not the page factory, but you could have the API factory. So you could have a web service factory where the automation layer is now actually going out and testing APIs.
Mm-hmm.
Does that make sense? Did that answer your question?
Yes, sir. Yes, sir. Yeah, absolutely. I'm still trying to wrap my head around testing design patterns, so I might be asking questions that are actually non-issues. So, thank you for your patience with me.
Oh, not a problem. And like I said, this is more an overview of the patterns. I
Mm-hmm.
am planning on going into specific examples with these in future lessons. So I'll actually continue on our hands-on approach that I've done with the TesgNG and Selenium, and we'll
Yeah.
actually break these down even further in actual use cases in the future.
Good deal.
Want to ask any more questions? Quickly review. So today we have covered the design pattern, from what the design patterns are, how they relate to developers and testers, and the importance of using design patterns. So the design patterns contribute to a major chunk in defining the test automation best practices. The benefits of test automation cannot be effectively without implementing the required design patterns specific to a test automation project. So like I said before, you go back and look at this. If you don't apply patterns, don't extrapolate out your test framework, you could end up with spaghetti. But whereas if you do it this way, you can easily interchange at the different layers of your test framework and easily adapt to your changing software development needs. So you can quickly adapt to any changes your software makes. You can quickly make changes to your test framework. Thank you. We know your time is important, and if you would like to discuss any additional questions or comments you have, you can check us out on info@developernerd.com. You can check us out on developernerd.com/contact us. We're on Twitter @developernerd, and we're also on facebook.com @developernerd. Our goal is making every developer better, so please check us out, ask us questions, and check out some of our other videos.